Here we are today with Unit 3, Lesson 4, Comparing Proportional Relationships. I'm going to try something just a little bit different today as far as the number of videos that are used here. As you can see with McGraw-Hill, this doesn't really give us a lot of help for making a table of represented situation. We're supposed to use the equation y equals 4 and 2/10 x could represent a variety of different situations. So what we're going to do, since you would have to do all these other pieces, feel free to do this in your book. But I'm going to give you GeoGebra, where we have the exact same question. It says, write a description of a situation. So the reason we want to bail on this one is because it's going to be a little bit harder to make our graphs and everything. We have to start from scratch, whereas over here, everything is all ready for us. So what we want to do here is come up with a situation. So the equation comes out this way: y is equal to 4 and 2/10 x could represent a variety of situations. Write a description of a situation presented by this equation. Decide what x and y represent in your situation. To do this, what we need to understand, first off, is that 4 and 2/10 is our constant of proportionality, which means that 4 and 2/10 can represent a wide variety of different things. Let's say that I decide that I want to, jump from spot to spot instead of walking. And I found out that every time I jumped, 2-foot jump, every time I jumped forward, I noticed that my constant distance every time I jumped was 4 and 2/10. So what I want to look at with this is I need to go ahead and create a situation here. With that situation, let's say that I can jump at a constant distance of 4 and 2/10 feet per one jump. Okay. What do we have to decide here? Well, we're going to say let x represent the number of jumps, and let y represent the total distance. Okay. Now, you are not allowed to copy my description or anything in the likeness of. I want you to come up with something totally different. But here's what you do have to do, and what I want you to make sure. In the table right here, I want you to go ahead and take this value of x, and I want you to, I hope you can actually modify this, but talk about this as calling this the, no, never mind. So right below it, we're going to put number of jumps, so you know what it is, and then we're going to let y be the total distance. When we talk about distance, we need to talk about what kind of unit we're using. So we're going to say total distance in feet. Now, we go back to that piece, and let's say if I take one jump, obviously, I'm going to jump 4 and 2/10 feet. If I take 2 jumps, then I get 8 and 4/10 feet. 3 jumps, you kind of get the idea here. 12 and 6/10 feet. And we see that that distance in there just continues to increase by 4 and 2/10 all the way out till we get to a reasonable distance. I'm going to tell you a little secret here. When you're looking at a fraction and you see that fraction is out to the 10th place, something that we can do with that is out to the 10th place. If we multiply by 10, that will make that a whole number. So that's one number I want to use in here because that's really going to help me out when I go to make my graph and I see with this information right now, I have to figure out what we're going to do here with my graph and such. I need to know how to be able to put my graph on here. And in order to be able to do that, what I should be doing with this is coming up with numbers that are going to make this pretty easy for me. One of those numbers that I didn't include is this. If I don't jump, then I don't travel any distance. And that 0, 0 is kind of nice because it's going to help us out to make a nice straight line. When I look at my numbers here, I see that 42 is the largest number that I need to do on my y-axis. And I see that 10 is the value that I need to get out to. So when I look at my axes here, I need to make sure to understand, first off, where is it that I'm going to put my text. So let's look at this. Let's go ahead and say the x-axis was the number of jumps. I can say okay, and then I can go ahead and click on that and drag it to wherever. And then my y-axis was the distance, oops, distance in feet. And I want to go ahead and drag that to a more appropriate place. And then I need to remember what numbers I have here. So I know that 0, 0, that's going to be easy to find. That'll be a point right here. 10 and 42, if I draw a point that goes from 0, 0 and draw a line that passes through 0, 0 and 10 and 42, it should automatically pick up all these points, no problem. And then I don't have to guess at all on these decimal numbers. And so what I want to do with this is, I know that I have to get out to 40 on this one. So I think an appropriate interval that I could use with this is probably going to be 5s. So that one would be 5, this will be 10. I'm not going to want to write everything, so skip a line. 15, 20, 25, 30, 35, 40. And I'm still left with a little bit of a guess out here. If I just did these in intervals of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then I want to come up to that one spot. 40 and 42 is just under a half. Whoops. So we'll say right here. And then the cool thing with that is I can just take my line and I can make a point there, draw it through there just under half, and voila. I have a nice graph that's going to represent my information. Now, perhaps you're saying, well, that line doesn't look right. Okay, we'll get rid of it. Grab the segment instead and start right there and just pull that off of the coordinate plane as far as you can. Make sure that it passes through an appropriate place, and then you have some good distance and some good information here. All right, that's it for this one. I'm going to do this in multiple parts.